Example 1, minting quarters. U.S. Mint specifications require that quarters manufactured after 1964 have weights with a mean of 5.670 grams and a population standard deviation of 0.062 grams. Listed below are weights, grams, of a simple random sample of quarters made with a new minting process designed to reduce the standard deviation so that weights of quarters are more consistent. Use a 0.05 significance level to test the claim that these weights are from a population with a standard deviation that is less than 0.02 grams. So here is the sample. And so what you would want to do is you can come in here in a StatCrunch, okay, and then once you open up StatCrunch, you can go ahead and title the column to be weights of quarters, and then you can put individually each particular weight of the quarters. So you can see here that when you put them all in, you're going to have a sample size of 24. So the one thing that you want to do here is you want to look for the sample size and the sample standard deviation, because that's what you're going to need for this problem. So if we go to Stat, go to Summary Stat, select Columns, we're going to select the weights of quarters. Make sure we select N and the sample standard deviation, and then select Compute. And so therefore, I'm going to go ahead and then copy this information. So there is our N and there is our sample standard deviation. So we want to be able to identify the following. We know that N is equal to 24. We know that in the claim, we can see that the population standard deviation is going to equal 0.062. And the sample standard deviation is 0.0480164. So there is our information that we need before we proceed. Now the requirements. It says the sample is a simple random sample which is stated in the problem. The population has a normal distribution. So this is a fairly strict requirement. So we want to be able to use StatCrunch and check in for normality. So let's go ahead and then open this up in a StatCrunch. And then what we're going to do is we're then going to generate a normal QQ plot to show that the points are reasonably close to a straight pattern. Otherwise, if not, then we won't be able to proceed. So let's go to Graph, select QQ plot, select weights of quarters, make sure we select horizontal lines and vertical lines, and then select Compute. And then here is our graph. So if we take a look at the graph, we can see that in somewhat, it does have some data. There's no strictly unique pattern that's going on here. So when we look at the graph here, we can say that it shows points that are reasonably close to a straight line, and there is no other pattern that is not a straight line. So therefore, there's our graph. Now, in part 1, it says state the claim and the opposite of the claim. Now, the claim is that the standard deviation is less than 0.062 grams, which is expressed as sigma, which is less than 0.062 grams. So we need to figure out the claim and the opposite of the claim. Well, since the claim is less than 0.062, the opposite of the claim is going to be greater than or equal to 0.062. So therefore, the opposite here contains the equality. And that tells us that the null hypothesis is going to have the equal sign. And therefore, the claim, which has the less than sign, is therefore going to be in our alternative hypothesis. So we can now identify the null and the alternative hypothesis. So the null hypothesis is the population standard deviation is equal to 0.062, and the alternative hypothesis is where the population standard deviation is less than 0.062. Okay, number 3, now we want to be able to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Now, this is a left-tailed distribution since the alternative hypothesis contains the inequality less than. And then we're going to select the significance level alpha. Well, if we come back up to the problem and the question, It says here that it wants us to use the 0.05 significance level. Therefore, alpha is going to equal 0.05. Now the next thing is we want to be able to then determine the test statistic for testing a claim about a standard deviation or variance. Using n equals 24, the population standard deviation is equal to 0.062, and we have the sample standard deviation to be 0.048064. So now what we want to do is plug into the test statistic formula. So we know that n is equal to 24, and then we're going to subtract 1. We know that the sample standard deviation is 0.040164, and then we need to square that. And then we know that the population standard deviation is 0.062, and then we need to square that. So therefore, there are our values that we plug in. Now let's go ahead and do this on our calculator just to verify. So let's go ahead and do that. So we have parentheses 24 minus 1 times, and so we're going to open up another parenthesis and put on our standard deviation of 0.04806164. And then we're going to square that result, and this is going to be in the numerator, so we're going to press enter, and that's the number in the numerator, and then we're going to divide it by parentheses 0.062, and then we want to square that, and then we get 13.795062 rounded to 6 decimal places, but we're going to round this to 3 decimal places because in the table in the back, when we talk about the chi-square distribution, it's rounded to 3 decimal places. So it's going to be 3.795 as our test statistic for the standard deviation. Okay, so now what we're going to do is we're going to draw our curve and label, and then use the p-value method, and then we're going to use the critical value method. So let's first do the p-value method. So the first thing we want to do is we want to draw our curve. Now remember that this is a chi-square distribution. So when we draw the chi-square distribution, okay, we see that we're going to have a 0 here, and it's going to look like a skewed right distribution. And now what we want to do is we want to then put our test statistic. So we want to find our test statistic. So our test statistic is 13.795. Now the reason why it's over here is because of the fact that this is a left tail distribution, which means we're looking at the left tail. So now let's go ahead and shade the region that we want to find here. So this is the p-value that we would like. So we want to find the p-value for the chi-square distribution. So the p-value is going to equal the probability of the chi-square test statistic, which is less than 13.795. So we're going to use StatCrunch to find that. So let's go ahead and now open up StatCrunch. Okay, and then what we're going to do now is we're going to use the chi-square distribution. So we're going to go to Stat, Calculator, and then scroll all the way down. Go to chi-square. Okay, so what else do we need to know? We need to know the degrees of freedom. So the degrees of freedom in our problem, we know is n minus 1. And therefore, we have 24 minus 1, which gives us 23. So therefore, that's our degrees of freedom. So we're going to put in 23. We know it's going to be less than or equal to because we're looking for the area over here. And then we're going to put in our test statistic of 13.795, and then that's going to give us the following p-value. So let's go ahead and then put that p-value here. So if we want to round that to 4 decimal places, we're going to get 0.0674 as our p-value. Now that we have our p-value, then we can make a decision. So reject the null if the p-value is less than or equal to the significance level. we fail to reject the null if the p-value is greater than the significance level. Well, comparing the p-value versus significance level, we have 0.0674, and that is greater than 0.05. Therefore, we fail to reject the null hypothesis. Okay, so how would we then use the critical value method? Well, first we want to find the critical value for the significance level of 0.05. Okay, so we want to be able to find the degrees of freedom, which is 24 minus 1, which is equal to 23. Okay, so now what we want to do is we want to find that critical value. Okay, now we know it's a left-tailed, and we have our significance level of 0.05, which means that that's the area in the left tail, and we're going to use the degrees of freedom for 23. So we're going to go to Stat, Calculators, and then go to chi-square. We're going to make sure our degrees of freedom is 23. Make sure that this is less than or equal to. And we're going to put in the area here, which is the significance level of 0.05, and then press enter. And then when we do that, we're going to get the following critical value. So let's go ahead and copy that, and then we're going to draw our distribution. Okay, so you can see here that we get a critical value here, which is going to be on the left side of 13.091 if we round that to 3 decimal places. So therefore, there is our critical chi-square value on the left. So let's go ahead and draw that distribution here. So here is our graph. Okay, we know that this represents 0, and we know that for chi-square it's going to be skewed right. And then what we want to do is we're going to go ahead and then put in the critical value that we found here. And this is the chi-square on the left critical value, which is 13.091. Okay, and then what we can then do is shade this area here that's going to represent the critical region. So therefore, this represents the critical region. And now what we're going to do is now use this test statistic. Okay, so where is the test statistic according to that? Well, the test statistic is going to be to the right of that. So 13.795 is the test statistic, and it's to the right of that value. And if you look at that, it does not fall in the critical region. So what does that tell us when using the critical value method? Well, you reject the null if the test statistic is in the critical region, and you fail to reject the null if the test statistic is not in the critical region. Well, as you can see here, since the test statistic of 13.795 is not in the critical region, then we fail to reject the null, just like we did using the p-value method. Okay, so now what we want to do is we want to state the conclusion. And so we need to look at all 4 possibilities. But in order to do that, we need to come back here and take a look at what the claim is. Well, the claim states that we have an inequality. So we don't have the equality, and we ended up failing to reject the null hypothesis. So of the 4 possibilities, then we're going to choose the following. Okay, we know that the original claim does not include the equality, and we failed to reject the null. So we would say that there is not sufficient evidence to support the claim that, followed by the original claim. So we would say the following. There is not sufficient evidence to support the claim that the listed weights are from a population with a standard deviation that is less than 0.062 grams. There isn't enough evidence to show that the new minting procedure is achieving the goal of reducing the variation of weights of quarters.